Hi everyone, my name is Ziv Goldfeld, and I'll be presenting a joint work with Christian Greenwald about sliced mutual information, which is a new and scalable measure of statistical dependence. But to get started, I think we're all familiar with classic mutual information that is defined, let's say, between continuous high-dimensional variables like so. And mutual information is indeed a fundamental measure of dependence with many good properties, like the fact that it nullifies if and only if our random variables are independent. It is invariant to bijections, admits several useful representations, decompositions, and variational forms. And in fact, it can even be obtained axiomatically as the unique functional of the joint distribution that satisfied some natural informativeness conditions. And as such, mutual information has seen a variety of applications in information theory, statistics, machine learning more recently. But the problem is that all this structure has a hefty price, since computing mutual information high-dimensional setups and furthermore estimating it from samples is very, very hard and effectively infeasible in practice. Now, to address this impasse, in this work, we introduce sliced mutual information, which, like I said, is a new and much more scalable measure of dependence, which is defined as the average of a scalar mutual information terms between projections of our high-dimensional random variables onto randomly chosen directions from the corresponding unit spheres. And this is an illustration of what's going on here. And the interesting thing is that despite these one-dimensional projections, sliced mutual information inherits many of the properties of the classic variant. For example, it also identifies independence. It has the entropy decomposition, chain rule tensorizes for independent copies, as well as admits a KL divergence representation that further gives rise to a Donsker-Vardhan variational form. And maybe another interesting observation to mention is that due to the nature of these projections, sliced mutual information no longer satisfies the data processing inequality which classic mutual information obeys, and can in fact be created from computation, which may be quite useful for feature extraction tasks. And this is a curious property, but I would not elaborate it more on it at the moment. And please do visit us at the poster if you would like to know more. What I would like to get into is really the justification for this entire framework, which is basically how easy and fast it is to estimate sliced mutual information between high-dimensional random variables. Roughly speaking, the idea is to combine your favorite scalar mutual information estimator with a Monte Carlo integration step, and we can show that if your scalar mutual information estimator admits a delta n, for example, error, then the sliced mutual information estimator we propose in the paper has the same error plus an m to the minus half additive penalty for the Monte Carlo step. So effectively, the rate we're getting corresponds to that of the scalar problem, which is typically parametric and therefore optimal under mild smoothness assumptions, perhaps up to some polylogarithmic factors. And if you compare this with the exponential dimension estimation rate for classic mutual information, we see that sliced mutual information indeed is able to avoid the curse of dimensionality, which is the real premise here. Now, this scalability makes running empirical experiments with sliced mutual information a breeze, and in particular, we examined it as a figure of merit for independence testing, basically just by thresholding the computed sliced mutual information value, and we compared the obtained results with the performance of the same test based on classic mutual information. For several different setups, this figure over here shows the area under the ROC curve as a function of number of samples. And basically, you want this number to be 1, which corresponds to an omniscient test. And it is clearly seen that while the sliced mutual information-based test scales well to the high-dimensional scenarios, mutual information fails in this regime. We have additional experiments available in the paper, but I think this is all we have time for. So thank you for listening, and please do visit us at the poster if you would like to know more.